this one was loud.
Yeah?
This one was loud.
Yeah, because I collected much.
Have you ever imagined why they say that water is composed of hydrogen and oxygen? Yes, this can be confirmed through the electrolysis of water using the Hoffman voltameter. This gives us two gaseous products which are hydrogen and oxygen in the ratio of 2:1 by volume. But water being a weak electrolyte, we need to acidify it, commonly with H2SO4, in order to increase the conductivity. The Hoffman voltameter is designed to collect the two products separately, and not only that, it will also give us the volume because it is calibrated. What I did was to acidify with a few drops of concentrated H2SO4 to increase the electrical conductivity like I told you. Then I added universal indicator in one of the acidified water to monitor pH change. This is just out of my curiosity. I took the pH using my pH meter, which is 0.4, that's before electrolysis. Then I have to unbox my Hoffman voltameter. Remember, this Hoffman voltameter is available for sale. The new one, different types are available. This one is the one that we use Ritter stand to hold. Then another form is the one that uses the white board that is standing vertical close to me. There you are seeing is a different type. Therefore, I have to fill with the one I did not color, that's acidified water. I fill it. Remember to keep the tap open. The taps of two arms collecting the gases for anode and cathode before you fill. Then I tilted it gradual to get my 0 to make sure that the reading for anode and cathode are all at 0. But when you fill it above 0, you can withdraw some of the liquid by pipetting it out, as you can see. Then I connected my source of electricity. Warning, you are advised to use DC, that's direct current, never you use AC. Don't use AC. Then I closed the tap when some of the air has been displaced. I closed the two taps simultaneously at the same time. So the electrode I used here are the platinum electrodes, which we have the anode and the cathode. The black wire is the cathode, while the one with the white is the anode. So make sure to use the platinum. Why? Because oxygen will attack graphite. Now, as the electrolysis proceeds, coming to the anode, you see about 0.9 cm cube of oxygen gas has been produced. So let us go to the cathode. You will see that 0.9 times 2 should be about 1.8. You see, it's closer to 2. So we have 2:1 by volume of hydrogen to oxygen. Then I have to collect some samples of the hydrogen gas and test it. Hydrogen gives us pop sound. Oh my god, I'm not pressing it right.
I wasn't taking it there.
And that confirms hydrogen gas. I collected now from the anode, that should be oxygen. Remember, oxygen rekindles glowing splint. When you insert it, it will relight it. I've exhausted the oxygen and there's no more relighting it, so I have to now discard the one without color and fill the Hoffman voltameter with the one I colored with universal indicator. Universal indicator is very sensitive to pH change. I produced this one myself. You can watch my subsequent videos where I made the universal indicators, and they are different colors from pH 1 to 14. So I tilt always to make sure that the 0 aligns well. And then I have connected the electrodes to source of direct current. Don't use AC, I repeat, use DC. So you see, gases is being evolved. Like I told you earlier, you close the two taps at the same time after allowing some air to be displaced out. So I've closed it, and as the electrolysis proceeds, you can see the evolution of gas, the bubbling of gas happening. So you see that at the anode, at the cathode, there is about 8 cm cube or 7 cm cube of the gas produced. Then at the anode, it is still half of that 7, about 3.5 or so. So it is obeying that ratio of 2:1 by volume of hydrogen to oxygen. Then this electrolysis marvels me. It has now changed. The color of the indicator has changed.
it becomes lighter, almost yellowish at the anode, but the cathode become more reddish brown. This might be probably because there is decrease and increase in pH. This was my assumptions, but towards the end, analysis showed that it is not. So you see the original color of the indicator, it is having the same color as the reservoir, but with time, it starts decreasing. Now I have to collect again.
That's powerful. So hydrogen gives pop sound. So we close.
Remember, if you collect from one of the electrodes without collecting from the other and close the two, they will no more obey 2:1 by volume.
I'm collecting more of the oxygen from the anode. Insert your lighter splinter, you release it. Insert again, it releases it. So that's great.
But why that sound? Why that sound?
Next, I will collect more. This time around, there is enough hydrogen gas produced now at the cathode. It's about 30 cm3.
Wow, this one was loud.
Yeah?
This one was loud.
Yeah, because I collected much. And I heard it direct, unlike the other one.
Okay, then after the combustion, do you know what happened? There was drops of water inside that test tube. So hydrogen is called hydrogen because it's a water former. After burning, it forms what? Water. So even when you electrolyze water, you get hydrogen. When you now burn hydrogen, you get what? Water again. So we go to the curiosity stage.
Collect this one. Let's compose the pH. This was originally 0.4. This was from the cathode. This was from the anode, the electrolysis of water. So we take. So what's this one reading? What's he reading?
0.4.
Eh?
0.4.
Still 0.4.
Yes.
So that was the pH of this one. Is this stable or is it going down?
Stable.
0.4 stable, right? Oh, yeah.
Still 0.4.
Why? Why then the change in color intensity? See that what's happening now? It's not pH that is causing it. Oh, this one.
Still 0.5 now.
5 better. Why there might be some contamination? This is 0.4, this is 0.4. How? This one
0.5 now.
is because of the contamination.
0.4.
Okay.
Zero
0.4. Okay. But why the color change intensities now? Raise this with flash of water, the sensor. What's the pH now?
3.1.
3.1, that's correct. That's what it's supposed to be. It's one, the range is 3.1 now.
1 still. It's stable.
Yeah. So this, it shows that the pH meter is correct. So the transition points for end point of this should be true. So when we put it back here, you get 0.4, 0.4. So probably the color intensity here is only because maybe the universal indicator dye is attracted to this negatively charged, which is the cathode. I wouldn't know why, because I was thinking that the different color intensities of the universal indicator is different pH. But the pH here is exactly the pH here, which is what it's supposed to be, because hydrogen ion is removed here, or hydroxide is removed, equivalent amount, so it shouldn't affect the pH. But why the color intensity difference? We'll tell you why at the time. Thank you.
Taller than the car now. 130.